Okay, we're back. Here we go. A little programming note. I was absent yesterday, so we're not doing this, we're doing this. All right, we're on 410. We skip 49, recording 410, okay? All right, so we're taking a look at 82AB4 related rates question. Let's do it. It's the same packet. Yeah, same packet. So 82AB4. Remember, tomorrow's AB day review, AP day review, right, in groups. And Friday's a test on all this fun stuff. Okay, we got a ladder 15 feet long. It's leaning against a building so that the end X is on level ground and the end Y is on the wall as shown in the figure. Okay, so let's pretend this is the figure. So this is the wall and this, whoops, that's the wall and that's the ground. Yay. And here's the ladder. Okay, so it hits, let's say this is the origin. Let's make an axis out of this, a coordinate grid. This is the X value, this is the Y value, right? So this X-intercept is where the ladder touches the ground. This Y-intercept is where the ladder touches the building. X is moved away from the building at a constant rate of 1/2 foot per second. Right, so we're pulling this away from the building at 1/2 foot per second. What did they just give you? No, that's not X. X prime, which is dx dt, right, okay. Dx dt is 1/2 foot per second. Right, to just remember the video, write down everything you can know, write down all the facts, figure out what you don't know. All right, yeah? Yeah, I don't get that crazy. She gets a little too crazy. Yeah. I don't write down everything, okay? All right, so anyway, A, find the rate in feet per second at which the length OY is changing when X is 9 feet from the building. All right, so if this length is X and this length is Y, it is, right? Because that's Y0 and that's 0Y and that's X0. And didn't they tell you the length of the ladder? The length of the ladder is 15 feet, right? Can you figure out how fast Y is changing if you know how fast X is changing? That's the question. And so how do you do that? Right, there's a relationship between X and Y, isn't it? It's what? X squared plus Y squared is going to be 15 squared, otherwise known as 225, but you don't have to write that. So how are you going to get the rate of change of Y? If the rate of change in X is dx dt, I'm trying to find dy dt, right? How do I get dy dt out of this? You guess? Differentiate implicitly with respect to who? T. So these are functions in time. So that's a chain rule. I'm not differentiating with respect to X. This is a function in T. I'm differentiating with respect to T. This is chain rule. This is chain rule, right? So what do you get? 2x dx dt. Yes, X prime among friends means dx dt. But X prime among friends does not mean dx dy or something else, okay? Be careful. Plus 2y dy dt is equal to 0. Yay. Okay, so what do we know? Well, they said find out what's going on at the instant that X is 9. So we know that X is 9. We know that, I'll call this Z is 15. Can you figure out Y? You need it. Can you figure out Y? Let's do it over here. X squared plus Y squared equals 15 squared. They're telling you the moment that X is 9. This is moving, right? You take a snapshot. At the instant that this is 9 feet, what's going on? There's a question, right? So there you go. That's a Y squared equals 15 squared. So how do you get Y? Subtract. 225 minus 81. Y squared is 225 minus 81 is 144. And that's convenient because you know why then. It's 12 feet, right? Okay, remember we're taking principal roots here because Y is the side of a triangle. We're not using negative Y's. Okay, so we know X is 9. We know Y is 12. We know dx dt is what? 1/2. By the way, I wrote down that it's a positive 1/2. Is that right? Why is it negative? No, I'm pulling it this way. That's increasing the length of X. Isn't that a positive rate of change? Yeah, that is positive. I just want to make sure you realize why it is positive and it has to be positive. Sometimes you have to interpret the question. You're going to write a negative here. But this, the Y is decreasing, isn't it? The length of Y? So you would expect dy dt to be what? Negative. So hopefully that's what we're going to get. All right, so you plug in 2 times 9 times 1/2 plus 2 times 12 times dy dt and solve for dy dt. It's just algebra now. Oh, it's so easy. So half of 2 is, well, 2, nothing, 1. And then 9 plus 24 dy dt equals 0. So now what? Subtract 9 divided by 12, 24, right? So dy dt is going to be negative 9 24ths. And if you want to reduce, you can reduce by 3, I guess, right? To negative 3 eighths. Don't forget units. Units in the question, units in the answer. What are the units? Feet per second. Okay, that's it. That's part A. Was that terrible? That's related rates. Finding dy dt from dx dt, because they're related. Okay, part B, you ready? Question? Okay, part B. Find the rate of change in square feet per second of the area of the triangle, XOY. Well, at the same instant, when x is 9 feet from the building. Okay, so what does that mean? That means don't reinvent the wheel, okay? You know that in part A, x is 9 and y is 12. Well, in part B, x is 9 and y is 12 also. The same instant in time. This is a constant 15 and this is a constant 1/2. This still applies. You have all of this information to play with. But now, what's the relationship between x and y? 1/2 xy is the area, right? Okay, so let's go to the next page. The area of the triangle is 1/2 base times height, right? Now, x and y are both changing. It's not the hypotenuse, which is a constant 15. X is increasing, y is decreasing. So these are both functions. So you're going to do what? How do you differentiate this? Product rule, chain rule, fun stuff, right? So what's the derivative of this with respect to time? The ADT is equal to, I'm going to keep the 1/2 out of this. Do a product rule. What do you get? First times the derivative of the second. What's that? dy dt. Plus y times derivative of the first. There you go. Okay, so you can figure out the ADT by plugging in stuff. Do you know x? What is it? 9. Do you know y? What is it? 12. Do you know dx dt? It's 1/2. Do you know dy dt? It's maybe 3/8. So just plug everything in and you're done. This is just arithmetic. Wow, I thought calculus was tough. It's arithmetic now. That's it. Just work this out. Okay, so let's see. You get negative 27/8 plus 6 times 1/2, huh? Well, maybe I should have left this 12/2, but how do you add these two? Tell the denominator, multiply top and bottom by what? 8, so you get how much? How many? 48/8? Okay, so I got 48/8 minus 27/8 times 1/2 divided by 2, and that's not 1/2. And so what's 48 minus 27? 21/8 divided by 2 is 21/16. Okay, and what are the units? Remember what we're trying to figure out? Square feet per second, right? If there are units in the question, there better be units in the answer. Be careful. Okay, that's all she wrote. That's it for that question. Was that terrible? Nah. Okay. How about we jump to 85AB5? 85AB5. 2 pages over. Okay, notice this is a BC2 also. The difference being, do you see what's in parentheses near the end of the question? Right? That wouldn't be on the BC test. You're expected to know formulas like that. Okay? So, but there it is. So pretend we're in AB right now. The balloon shown above is in the shape of a cylinder with hemispherical ends of the same radius as that of the cylinder. The balloon is being inflated at a rate of 261 pi cubic centimeters per minute. At the instant that the radius of the cylinder is 3 centimeters, the volume of the balloon is 144 pi cubic centimeters, otherwise known as cc's. And the radius of the cylinder is increasing at a rate of 2 centimeters per minute. The volume of a cylinder with radius r and height h is pi r squared h. Did you not know that? Didn't we do the can problem last week? the Pepsi can? Yes. And the volume of a sphere is 4/3 pi r cubed. Okay. At that instant, what is the height of the cylinder? Right? Alright? Okay. So, well, let's see. What's the volume of this crazy thing? Can you give me a volume formula for this shape? Okay, this is 85, right? You have a hemisphere on the top. I'm not going to draw it here, but you have a hemisphere on the top and a hemisphere on the bottom, but they're congruent. So it's as if you had a whole sphere, right? So that would be 4/3 pi r cubed for the top part and the bottom part, plus the volume of the cylindrical part is pi r squared h, and that's your volume. Okay? Now remember, they told you the volume. What is it? No, that's right, it changed. 144 cc's, 144 pi cc's, that's different, okay? And they told you at the instant that the radius is what? They want to calculate this the moment that the radius is 3. So just plug this stuff in and guess what you can find out? You're just going to get h out of this, right? Okay, right away, the pi's can be canceled, so ignore them, they're not there. So I'm going to write it this way, 144 pi equals, now let's see, 3 into 3 cubed is 3 squared, right? And 3 squared times 4, well, 3 squared is 9 times 4 is 36, plus 9h. So, now what? Whoops, this pi went away, right? So subtract 36 from 144 and you get 108. Oops, I lost my pen. 108 equals 9h. So, h is 12. What are the units? Didn't they give you units in this problem? This is in cubic centimeters. This is in centimeters. What's this? Centimeters. Better label your answers. Okay, that's it. That's the height of the cylinder. You might need that later on. That's not calculus. Okay, but you might need that. Okay, so you have a lot of information. At this moment, that's the volume. At this moment, that's the radius. At this moment, that's the height. And they also gave you a rate of change. Where the heck is it? The 261 pi cubic centimeters per minute is what? dV dt. Right. And the 2 centimeters per minute, what's that? The RDT. So you have a lot of information here, right? Okay, part B. At that instant, how fast is the height of the cylinder changing? Okay, so we're going to take our volume and differentiate it, right? Implicitly with respect to what? Time. Okay, so let's just freeze our volume here. So, dV dt. Let's see what it is. What do you think you get when you differentiate this? What do you get? This is a constant, this is a constant. 4 pi r squared, what's missing? dr dt. Because in other words, we're not differentiating with respect to r. That would be it. We're differentiating with respect to t. There's a function in t, so you got the chain rule. Okay, plus. All right, now, this is a product rule, right? Because r and h are both changing. So let's say, I don't know, I'll leave pi out of this. First times the derivative of the second plus, what should I write? What do you write next? H, the second times 2r dr dt. Derivative of the second. All right, the first times derivative of the second plus the second times derivative of the first. There it is. All righty, so let's plug in what we got. We know r, don't we?
Yeah.
What? 3. Okay, I'm going to plug that in. It's 3. By the way, we know this too, right? Didn't they give you this? 261 pi cubic centimeters per minute. Okay. Okay, so we got that, we got that, we got that. What about this? This is 2 centimeters per minute. Okay. Plus pi times, well, again, this is 3. Right? Yeah, it is. Okay, so 3 squared. The HDT is what you were calculating, right? Didn't they say find the rate at which the height is changing when you're inflating the balloon, basically, right? If the rate of change of the volume is positive, you're inflating the balloon. So how fast is h changing, it's going to be a positive the h dt probably, yes? Okay, plus, now what was h? We calculated it in part A, didn't we? 12 times 2 times 3 times 2. Okay, it all boils down to arithmetic again. Again, the pi's go away, right? So 261 equals, and you'll get 6 times 4 is 24. Oh, it's squared, I'm sorry. So that's a 9, and yeah. 6 times 9, what? What? What did you say? It's 8 times 9, 72, right, 72. Okay, 70, yeah, I know how to do this. Okay. Plus, now I don't need these parentheses because the pi is gone. That's all the parenthesis was there for distributing pi. It's gone, right? So plus 9 dh dt. And what is this whole mess here? Say 2 times 2 is 4, times 3 is 12, times 12 is 144. Oh, wow, that's my favorite number. Keeps on coming up. Okay, so let's see. Let's combine stuff. 172, 72 and 144. Is how much? 216? 216 plus 9 dHdt is 261. Is that right? Yeah. Right. Da-da-da-da. Why does that sound right? That is right. Okay. And if you subtract 216 from 261, you get 45. Perfect. Okay, so it's 45 equals 9 dHdt. So dHdt is simply 5. Don't forget the units though. 5 watts. Centimeters because it's H. Per minute because it's time. There you go. Perfect. Alrighty. Yeah, in the interest of harmony with the next teacher, I'm going to stop recording here. But let's go to 94AB5. Okay, I'm going to have to stop recording right here.